नमस्ते विद्यार्थी मित्रांनो. Today we are going to study most important topic of physics, that is refraction of light. In this chapter we will study refraction, laws of refraction, refractive index and dispersion of light, presented by Sri Shankar Bhujbal from Sri Chhatrapati Sambhajiraje Madhyamik Vidyalaya, Jatega. So let's start study of refraction of light. We know light rays always passes in a straight line in a transparent medium. But when light rays coming from one transparent medium enters into the another transparent medium, it changes its direction. This is called as refraction of light. The light ray coming toward the surface is called as incident ray, and the light ray that change its direction after refraction is called as refracted ray. The perpendicular drawn from the point of incidence is called as normal. The angle made by incident ray to the normal is called as incident angle, and the angle made by refracted ray to the normal is called as angle of refraction. From this we can state the laws of refraction. First law: the incident ray, refracted ray are lights on opposite sides of the normal in same plane. Here incident ray is on left side of the normal and the refracted ray is on right side. So they lies on opposite side of the normal. Then second law: for given pair of transparent media, the ratio of sin I and sin R is constant, called as refractive index. Formula of refractive index is n equal to sin I upon sin R. Some more information about refractive index. Refractive index of light for given pair of media is constant. Refractive index of a medium for light of different colors are different, and also different media has different value of refractive index. Refractive index of a medium with respect to vacuum is called as absolute refractive index. If light rays passing from one transparent medium to second, then the refractive index of second medium with respect to first is written as 2n1 equal to v1 upon v2. v1 is the velocity of light in first medium and v2 is the velocity of light in second medium. And if light coming from second medium enters into the first medium, then the refractive index 1 and 2, that means refractive index of first medium with respect to second medium, is equal to velocity of light in second medium v2 upon velocity of light in first medium v1. Now the refraction of light in different media. Suppose light ray coming through a rare medium enters into the denser medium, then the refracted ray turn closer to the normal. And if light ray coming through a denser medium enters into the rare medium, then the refracted ray go away from the normal. And if the light rays coming perpendicular to the surface in the transparent medium enters in straight line without deviation as shown here, So this is about the refraction of light in different pair of media. Effect of atmospheric refraction of light. The refractive index of air goes on increasing with the decreasing atmospheric height. So starlight when entering into the atmosphere, it gets bent down due to atmospheric refraction. Hence the apparent position of star is slightly above from its actual position. Thus, sun rises 2 minutes earlier and sunset 2 minutes late every day. Then another effect of atmospheric refraction, that is miracle. The air on the surface of road, desert and around fire becomes hot and rare. The refractive index of such air is less as compared to surrounding air. So light ray coming from the distant object bent upward, the object appears like its outer image. This is called as miracle. For example, rays coming from this tree on when entering into this ear having less refractive index, then it turns upward like this. So we feel the rays coming from this point and the tree is appear like its outer image. This is called as miracle. Then the splitting of light into its component color is called as dispersion of light. When white light enters here into the prism due to refraction, different colors of light, component colors, goes in different direction. That means get separated from each other. On another side, the emerging light color rays of light go in different direction, so we get a color band called as spectrum. This phenomena is called as dispersion of light. Scientist Isaac Newton used prism for the splitting of white light first. Look here. Then partial and total internal reflection. When a light rays arising from a denser medium enters into rarer medium, this is denser medium like water or glass, and this upper medium is air, rarer medium. If the light rays coming perpendicular to the interface of two media, then the incident light goes straight forward without deviation. But the incident light ray coming with an angle of incidence less than 90 degree, then the refraction of some light rays in this direction and some part of the light get reflected in the same medium. This is called as partial reflection. If we increase the angle of incidence, then angle of refraction also increases. Also partial reflection takes place. If we increase some more the angle of incidence, then the refracted ray go perpendicular to the normal in this direction. At that time, the value of angle of incidence is called as critical angle, and the ray of light does not go into the rarer medium. At the time of critical angle, the refractive index 1 and 2 is sin I upon sin r. The angle of refraction is 90 degrees, so the sin I upon sin 90 equal to sin I. I is the critical angle here. Critical angle is the angle of incidence at which the angle of refraction is 90 degree. If the angle of incidence is more than 90 degree, critical angle, then the incident light on reaching on the surface of interface in between this denser and rarer medium turn back into the denser medium. This is called as total internal reflection. Then last part of this chapter, that is rainbow. Here, when sunlight entering into water droplets after rainfall, minute water droplets in the air, the light rays refracted, then total interreflection of all components colors, and finally again refraction when light enters from water droplet to air. The colors get separated to form a beautiful phenomena called as rainbow. Rainbow is the fleeting effect of light refraction, total internal reflection, and dispersion of light. Thank you, student, for watching the videos. If you like the video, share to your friends and subscribe our channel.